This is part 4 of the geometry review where we're going to cover proofs. So let's jump straight into it. Question number 31. We've been given the information that side BC, this side here, is congruent to side DC. So I'm going to go ahead and mark those. We also know that side AC here is congruent to side EC. And we want to prove that triangle BCA is congruent to triangle DCE. We have our first statement is our given statements. And we know that our second statement has the reason that vertical angles are congruent, so the vertical angles theorem. When you see vertical angles, you know that we've got this common vertex in the middle where the two triangles touch. So I'm looking for this angle and this angle across from each other. Because they all meet at point C, this is when we have to use 3 letters to define our angles. So I'm going to define my first angle as angle BCA with C in the middle because that's where they meet. And I want to say that angle BCA is congruent to angle DCE. And I know that that's how they match up because it's the same in the triangle statement. But I do know that B matches with D, C obviously matches with C, and A matches with E. So that's how I can say that. And now we know that these two triangles are congruent because of the side angle side theorem. And I'm just going to put THM for theorem. On the test, you would be likely to only need to fill out like this reason number 3 or like reason number 2. It's not very often that they give you the statements to fill out. It's more often the reasons, but you may still see them. All right, let's move on to question number 32. We've been given side JK is congruent to side LK, so there's those. And we know that side JM is congruent to side LM. That is our very first statement. I know that the reason is that this is given. And then my second reason is the reflexive property. Reflexive property is always when you have this common side, this shared side of a triangle. So I can say that side KM is congruent to itself, because that's what the reflexive property means. And since that's the case, I know that triangle KJM is congruent to triangle KLM by the side theorem. Okay, wonderful. Now, let's look at a slightly more difficult problem. I've been given that angle N and angle Q are right angles. So I'm going to mark those. There's angle N, and here is angle Q. I've also been given that angle NPO, which is this one here, is congruent to angle QOP, which is this one here. Okay, let's look at what we've got. So the first statement is our given statement that angle N and angle Q are right angles. Now it says triangle ONP, that's this top half of the rectangle, and triangle PQO, this one here, are, well, these have to be right triangles because one of their angles is a right angle, and that's the definition of a right triangle. I do know that OP is congruent to itself by the reflexive property. Angle NPO congruent to angle QOP, well, that was one of our given statements. And then based on all of the things that I have marked, my last statement needs to be what I'm trying to prove. So triangle ONP congruent to triangle PQO, and that is by the angle side theorem. Okay. Number 34. Side CB is congruent to side AD, and you can see these are already marked here. And then it says that that length CB is parallel to AD, and that's what these two little triangles here are, marking that those are parallel. If these lines are parallel, then we've got 3 transversals that cut through them. And if it helps you to kind of visualize it, you could extend these sides so that it looks a little bit more like two parallel lines cut by some transversals. All right, let's look through what we know. We know that side CB is congruent to side AD because that's a given statement. And we know that CB is parallel to AD because that's also a given statement. Our third statement is that angle CBD, which is this one here, is congruent to angle ADB, this one here. If I have two parallel lines and they are cut by this transversal here, then these two angles have an angle relationship. We know this because they are alternate interior angles. Then we know that side BD is congruent to itself by the reflexive property. And so we need to change this because this is quite obviously wrong. But then we know that triangle BCD, which is this top one here, is congruent to triangle DAB by those markings match side angle side theorem. Okay, last one. 35, we have been given that angle G is congruent to angle L, and that side GK is congruent to side LK. So, first reason, angle G congruent to angle L is given. Second statement, side GK congruent to side LK, also given. Now, this third one, angle GKJ, this one here, is congruent to angle LKH, this one here. Well, if I look at how they are marked and where they show up in my diagram, I can see that that both of these triangles meet at point K. When I have two angles like this across from each other, that is because they are vertical angles. And so my two triangles are congruent by angle side angle theorem. And that concludes our geometry review.